Welcome, everyone. My name is Clint Armistead. I'm the sales manager for North, Central, and South America here at Isograph. Thank you for joining us today. As a point of introduction, I just wanted to let you know a little bit of the history of Isograph. Isograph has been building engineering software for 32 years. Our headquarters is based in the UK, and we have a beautiful office here in Alpine, Utah. I'd like to introduce to you Dr. David Wiseman. He will be presenting our discussion today on the system safety assessment. He is our lead technical support based in the UK, has over 13 years experience here with our software at Isograph, and has literally worked with thousands of organizations helping their employees become more conversant with our software tools. So today David will be giving us a high-level overview of our system safety assessment module. And just so you have our information here, let me just share this with you. If you find this information useful today or would like to learn more, please feel free to reach out to us. We have our contact information for both the USA and Canada, as well as overseas. And you can certainly visit our website at isograph.com. So without any further ado, I will turn over the controls to David to take the reins and present this topic to us today. Thank you, David.
Yeah, thanks very much, Clint. So if you'll bear with me for a moment.
Yeah, let me see if I can get the controls over to you here. There you go.
Okay. So hi, everybody. My name is David Wiseman. I work in technical support and customer training for Isograph here in the UK. So today I'm going to be showing you around the system safety assessment module within Reliability Workbench. So that's what you should be able to see on your screen at the moment. Just a little background, Reliability Workbench is a modular suite of reliability analysis software tools, encompassing things like FMECA, fault tree, and a variety of other analysis techniques. We will be visiting a couple of those during the course of today's video because, of course, these facilities do tie into the system safety assessment, and we'll see how all of that works as we go along. So the system safety assessment module originally was developed for the aerospace industry in keeping with standards like ARP 4754 and 4761 to allow you to basically list all of the hazards that might occur as a result of functional failures in your system, allocate probability requirements to those hazards, and then compare those requirements to the predicted probability of failure coming from analyses like fault tree and FMECA. So when you set out with your system safety assessment analysis, how you proceed is going to depend on potentially which industry you're in, whether that's aerospace or another industry which might find this facility very useful, the automotive sector. So in the automotive sector, of course, there is this concept of HARA, hazard assessment, analysis and risk assessment. The system safety assessment module is completely equipped to handle that kind of analysis as well. So when you start your analysis, you might begin by going to the special functions menu and selecting one of our predefined templates. Now, you can just stick with a custom template, which would allow you to put in all of your settings manually. It's all completely customizable. You can set up your own requirements, set up your own failure classifications, but you can base a lot of this from information that's preset by certain standards. So, for example, ARP 4754 for aerospace, or ISO 26262 for the automotive sector. So if I were to, for example, choose ARP 4754 and click OK, This is going to ask me if it wants me to set up everything according to the standard. I'll click yes. And what the program will do is, for example, set up some classifications, set up a list of classifications that represent how serious a certain failure or hazard is expected to be. And if we open one of these classifications, maybe the major classification, you can see it sets the probability requirement and it sets the development assurance level, or DAL, automatically. So in this case, for a major problem, we have a DAL C and probability requirement of 10 to the minus 5. Now it's completely analogous if we do this for ISO 26262. It will create a list of classifications according to that standard, and it will allocate, instead of a DAL, it will allocate a severity class. So for those of you in the automotive sector, of course, the severity class goes towards determining the ASIL. And you can see there, you can select those from the drop-down box. Again, all of this can be set up manually if you prefer to do this by hand and customize it in certain ways, but this might just save you a little bit of busy work at the start of your analysis. But of course, at the heart of any SSA or HARA is going to be the failures or the hazards that you're dealing with. What the safety assessment module allows you to do is set up a hierarchy of functions and sub-functions that are performed by your system. So I can double click and say, okay, this is my system. I can give that a name. I'm going to give it quite a general name and click OK. And then beneath that, I can build a hierarchy of functions. So I can click add a function. I can give that function a name and descriptive information. Click OK. And that function is added to my hierarchy. And I can add additional functions at the same level or below that. So I could say, add another function, give that a description. Again, I'll just keep it quite general. I'll just call that sub-function. Click OK. And as you can see, you can start to build a hierarchy of these functional blocks. Now, as with virtually all the modules in the software, the program will not limit you on the size of the hierarchy or the number of blocks that you can add. So this could be as big or as small as you need it to be. So once you have your functional hierarchy, the program will allow you then to start adding failures. And you can add those failures at any level of the hierarchy you want. So these are maybe the functional failures associated with a given function or sub-function. So I can add a failure. And again, I'll just call that something very simple. Now, you can see there's quite a lot going on here. For one, we can allocate 1 to 3 different effects to a failure. Now, you can see there the categories are safety, operation, and passengers. These categories are customizable, so you can change the names of these if you need to. I'll just add that for the moment. We will come back to this dialog shortly. I'll add that failure. You can see that pops up in the hierarchy. I'm going to create maybe an effect. So you can see here the effect categories. If I double click one, I can just demonstrate how you can, of course, customize that if you want to. I will just add a safety effect. So maybe I'll do that in the add menu. And, you know, I might call that sort of, I don't know, critical or something like that. And I can add this effect, but you can see at the bottom, I can also allocate a classification to this effect. Now, we saw earlier that we were able to add those classifications as part of a template. You can see them there, or you can add them by hand, as we discussed. So those are already in place. So I can allocate a classification to this effect. So I might just say that this is catastrophic. So maybe my critical safety effect is classified as catastrophic. So now what should happen is I can go to my failure, I can allocate the effect, and you can see that the classification is pulled through. And of course, it will pull through the DAL, the DAL as well. So I now have a failure. It's been allocated an effect, and with that effect, we have the classification. Now, one thing I didn't show there, if we bring back our failure, is we can go to the verification tab, and you'll see the probability requirement is displayed here. This is being inherited from the classification, which of course is being inherited in turn from the safety effect that I've allocated. So I know that I need to make sure that this failure does not occur with a probability greater than 10 to the -9. Later, I'll be able to compare that to the prediction coming from another analysis to see whether or not I am complying with that requirement. So I will click OK. So there are a variety of other things that we can apply here. For example, phases and environments. Certain failures may only be a threat or only be a problem during certain phases of operation. So in aerospace, for example, maybe a certain problem is only a hazard during takeoff and landing, or in automotive, it might be only during the startup phase or only while driving on a highway at high speed. So we can add phases. And it could be, again, startup, shutdown. It could be takeoff, landing. I might call it something like takeoff. And I can even optionally specify duration. This information can be used to weight the probability analysis later on. So the probability will be adjusted according to how long this problem poses a threat. Again, that's optional. I can create one or more phases. And then for a given failure, I can say which phases is that going to be a problem. Now, one of the more involved aspects of setting up your failure is the environment. So you can tell the program, a little bit like with the phases, that a failure is only a hazard during certain or in certain environments. So maybe when the roads are icy, or when there is a crosswind on a runway. You can see here that there are 6 different categories of environment. They are preset, but again, you can double click those and change the names. So you can set that up however you want. So, I might say surface conditions. I can add an environment and say, icy conditions, and that can be I can set a probability for that as well. That again will weight the probability calculation later on. But again, that's optional. You can just leave it as it is. So I can add more environments. So I might say, traffic environments. I might say, high traffic. Operator. Maybe I'll set weather conditions, add the environment, and I'll say raining or something like that. So I can set up a whole list of these different environments. And again, for the failure, I can come back, go to the environment tab, and just check the box next to the relevant environments for this failure. However, there is another approach that we can take. What we can do is set up something called a situation, or in some sectors, people prefer to call it a scenario. It's basically the same thing. It is an environment or a set of environments that describes a scenario in which a certain failure might occur. So I can create a situation, so to speak. I say, okay, situation, I'll just give that a very general name. And I can say high traffic while it's raining. So this is my situation, rain and high traffic. So I can select a combination of these different environments. And that will form my situation. Now, again, for automotive users, you can see here that for a given situation, you can allocate an exposure ranking. Again, of course, that goes towards determining the ASIL. So I will create that situation. And if I go to my failure and go to the environments tab, now instead of checking boxes next to environments, I can simply say this failure is a problem in this situation, and you can see it automatically then checks the relevant environments. It will now inherit the exposure ranking from the situation that I've created at the bottom here. And again, for automotive users, you can see there that you can also specify the controllability ranking. So now from the ISO 26262 perspective, we have those three key rankings: the severity coming from the classification, the exposure coming from the environments or from the situation, and the controllability, which again we can set here on the environments tab. Now, there are a few other qualitative bits of information we can provide. We can create objects that represent detection methods. So if you have a certain inspection or a certain software routine that checks for a problem, you can just create a little object called a detection method and then link that. There's no numerical information really that comes with it. It's purely information. You can link to documents, essentially create a hyperlink to Word documents or Excel documents or other external sources of information. So if somebody wants to read a document describing this failure and the things that we do to mitigate or prevent it, you can link that here. And there are, of course, a variety of text fields that you can populate with any additional information that you need to. And those text fields also have a customizable header. I'll click OK. And now there is one more thing I'd like to show you before we start talking about linking to other analyses. Now, I've shown you there that you can specify a probability requirement through the classification and then feed that through to the failure. But there is another way of approaching this as well. You can create what we call a requirement. So these would be analogous to things like requirements and safety goals in the automotive sector, for example. I can add a requirement and I can basically say, okay, well, I'll give it a very simple description: prevent failure. And then click OK. And if I go to my failure, I can link that to the requirement. So I can say, I want to search for a requirement. That's the one I want. And of course, I can have a list of requirements associated with any given failure. So I can link that requirement to my failure. Now, if I go back to the requirement itself, it should inherit the DAL and also the verification probability, if that's the way that we are approaching the analysis. So what would happen is that we can create the failure for a given situation, give that a probability requirement, and then attach the requirement object to that, and the probability requirement will simply be fed through. So then we have the choice: do we want to link the failure directly to our fault tree or FMECA, or do we want to link via the requirement, link the requirement or the safety goal to the probability, to the fault tree or to the FMECA analysis? Now, for this example, I'm going to keep it quite simple. Maybe I'll just link to the failure directly. So one of the great things about working in a tool like Reliability Workbench, where you have this integrated environment with a variety of different tools available, is that those tools can share information. You can pass information from a failure rate prediction analysis to a FMECA or a FMEDA. From that, you can pass information to a fault tree and so on. All of these different analyses can share data, so it's all integrated, all linked together. And it's no different with the system safety assessment. Here, we've gone through our SSA or we've gone through our HARA, and we've identified a failure, we've ranked it, and based on that ranking, we've said it has a certain probability requirement, a certain probability that we have to meet in order to satisfy our ranking. And of course, what we're going to do next is then compare that probability to the predicted probability of failure coming from another analysis, like a fault tree, for example. So I will open up my failure again, go back to the verification tab, and what I can do is just click data link, and I can go and find an object to link this to. So you can see in the middle here, I can choose from all kinds of things depending on what type of analysis I've done, whether it's a fault tree or a FMECA or even a block diagram or a Markov analysis. Now in my current project, I don't actually have a fault tree or anything like that available to me, but that's not a problem because one of the things that you can do is link to an analysis in a completely different project if that's appropriate for what you're doing. So I could say, okay, I'm going to go and link to an external project. Going to browse to find that, if you'll bear with me for a moment. Maybe it's that one will do. And I will open that. So now I should be able to choose from the gates that are in that project. So maybe that one, and okay. So you can see there, it's pulling through the probability that's been calculated for that fault tree. So I click OK, and there's my my failure. I'm looking in the grid at the moment at the verification view of my data, which is going to give me a list of my failures, the information that they're linked to in another analysis, and whether or not I'm meeting my requirements. And of course, we can see there's the probability coming from the fault tree, there's the requirement, and the probability from the tree is significantly higher than the required probability. So naturally, that's saying I'm not achieving my requirement. So I'm going to have to go back to the drawing board and see what I can do to make my system more reliable. And just a little side note, you can see there, it's showing the name of the gate that we're linked to. If I were to click on that, that would take me to that gate. So if it was in the same project, it would automatically send me to the fault tree module and show me the gate. Or in this case, it would actually open up a second Reliability Workbench window displaying the fault tree that I'm linking to. And of course, as I've mentioned before, that works with all different types of analysis. I can link to a FMECA block or a FMECA failure mode. I could link to a reliability block diagram if that's my preference. And you can link to multiple different analysis types in a single project. In fact, I can actually show you how that would work. I'm just going to open up an example project. This is one of the examples we actually provide with the software as well. So certainly, if you are downloading the software and having a try this for yourself, it's certainly worth taking a look at this project also. So in this project, I've got several failures. And as you can see, each of those failures has its own probability requirement. It's linked to a different analysis. I've got one linked to Markov, one linked to fault tree, one linked to reliability block diagrams. So again, you're not limited to just linking to one project or one analysis technique at a time. You can link to a variety of different things in a variety of different locations. So that's an overview of the system safety assessment module. Again, I guess the main takeaways here is it will give you a formal framework in which you can build your system safety assessments for aerospace, or your HARA for the automotive sector, identify the failures, rank them by, say, Dow or ASIL, and thereby give them a probability requirement, and then compare the predicted probability from a fault tree or another analysis to that requirement and determine whether or not you expect to meet with the probability requirement for the given Dow or ASIL. Yeah, so that's everything I was planning to cover for the main part of the demonstration. So Clint, did you have any comments or questions about that?
Just a couple of things, David. And I think you touched on this in the beginning when you were talking about like a custom template. So if I go through and I set up all of my classifications and hazards and they're all going to remain the same from project to project, you can go ahead and and basically capture this template that you've created. So for the next new project, you could go ahead and pull out that shell, for lack of a better term. Is that the case?
Yeah, so you could do that. So while it wouldn't be through the special functions menu, as this is a kind of static dialog, what you can do is use the program's integrated library facility, which basically lets you link one or more projects as a library, and then drag and drop information from one to the other. So you could set up lists of effects, lists of classifications, even functions and failures, attach them as a library and just drag and drop them into a new or existing project. So that's probably the best way to approach templating.
Would you also touch on, let's say that they, a prospect is coming over with maybe like some spreadsheets or libraries built out, maybe in a different format. Can you just touch on, what the options are for some of those projects that may not already be in the workbench?
Yeah, so besides the library, there are other ways of getting data in and out of the program. Primarily what you have is very powerful import and export facilities that you can access via the file menu. I'll just pull up the import dialog to illustrate. So you can import and export data from and to formats like Access and Excel, and other things like SQL Server, even simple text files like comma delimited or tab delimited. Now, in principle, you could completely construct your project from an Excel file if all the data was in there. Normally, that wouldn't be the case. You'd probably just have, say, a list of the classifications and effects, the list of environments that you plan to use, already listed in an Excel file. You just import that, and it saves you, some tedious minutes and hours of work setting up your project. You just get that data straight in, and you can get straight to work then on your safety assessment.
That's perfect. Anything else that you wanted to add, David? I mean, this has been a great overview. I really appreciate you taking some time with us today.
No problem. Probably just to point out that, as with all the modules of Reliability Workbench, there is a report facility that will allow you to build reports based on the data in your project. This works by opening a report template, which will automatically populate with data from the current project. And these reports can take a variety of formats. Generally, it's a text report for tables of data, graph reports. Where modules like fault tree and block diagrams are concerned, you can also output the diagrams as well. We provide a library of standard report templates with the software, but you can modify those to your own needs, and you can create your own as well. So this is another method really of getting information out of the tool, besides just looking at the output or exporting it to Excel. You've got these reports that give you a kind of formal layout for your data, and naturally that can be exported to the likes of Word, to PDF, or even to text files that you could open in Excel, again like CSV and so on.
Well, I think that's great. Hey, thank you so much, David, for taking some time with us today. And just to conclude our presentation, I'll include our contact information one last time. If you have any questions about what you've seen today, or just would like to take advantage of using such a great tool, please feel free to reach out to us. Hey, thanks again for all attending. And thank you for your time today, David. Everyone have a good rest of your day.